Okay, so let's look at number 11 and 12. We want to find the derivative of both of these functions. And let's notice they are fractions, and so we're going to need to use our quotient rule. So I've rewritten these on a sheet back here. So let's do these. And let's remember our quotient rule is the following. We're going to take the derivative of the top times the bottom minus the derivative of the bottom times the top. Put that over the bottom squared. Now let's realize that the f and g in the quotient rule refer to the top and the bottom of the fraction, not this f out here. All right, so think of f as the top of the fraction and g as the bottom of the fraction. All right, so let's do our quotient rule on this. According to the quotient rule, we're going to take the derivative of the top. So the derivative of negative 9x to the 8th will have 8 times negative 9, negative 72, and lower the exponent, that would be x to the 7th. And then our quotient rule calls for the bottom, g, to tag along. So we want x plus 7. Now our quotient rule has a minus sign, and I want to do the derivative of the bottom. So the derivative of x plus 7 is just the one that's in front of the x, because the derivative of 7 is 0. So we'll just have 1. And then we want f, our top, to tag along. So negative 9 x to the 8th. Now all of that goes over the bottom squared. So x plus 7 squared.
Excuse me, man. Do y'all do the GED pretest today?
Sorry, I'm in my office and there's some noise in the background. All right, now we're going to multiply out everything on the top. We're going to leave the bottom alone. So let's distribute negative 72x to the 7th through this set of parentheses. So we'll get negative 72x to the 8th. And then negative 72x to the 7th times 7, which is negative 504x to the 7th. And then multiply our negative 1 times our negative 9x to the 8th, and we'll have positive 9x to the 8th. Kind of getting low on space here. I should have put that one further down. All right, but let's add like terms. The negative 72x to the 8th and the positive 9x to the 8th. I'll try to squeeze it in here. So that's going to give us negative 63x to the 8th. Minus the 504 x to the 7th. And all over that bottom square. And that is our derivative. Okay, so that's the answer you will put in the box. All right, now let's do the same thing on the second one here. All right, so our quotient rule says to take the derivative of the top. All right, so derivative of the top will be 4 times the negative 8, negative 32. Lower the exponent, that's x to the 3rd. Bottom tags along, x minus 5. And then we want a minus sign. Now the derivative of the bottom, well, that's just going to be 1, and the 5 is going to go away, so just 1. And now the top tags along. And then we want all of that over the bottom squared. So over x minus 5 squared. Now we can leave the bottom as it is, but we do need to distribute the top and add like terms. So negative 32x to the 3rd times x will be negative 32 x to the 4th. And then negative 32x to the 3rd times negative 5. That's going to give us 160 positive 160 x to the third. And then over here, negative 1 times negative 8 is going to give us a positive 8x to the fourth. Oops, sorry. Problem with writing with your mouse is you get lots of silly mistakes like that. All right, and then let's add our negative 32x to the fourth to our 8x to the fourth, and we'll get negative 24 x to the fourth plus 160 x to the third all over that denominator. And there it is.